Well, good morning. Are you able to hear me clearly with the mic way we have it set up? Okay, great, good. It will help me to know how to gear things if I have just a quick idea. How many of you have done some sort of graduate work in genetics? Is that, yeah? Okay. Some? What, is it related to your current profession or? Pediatrics, okay. Oh, tremendous influence and impact in pediatrics. Okay, we might use you as a resource, we'll see. Okay. How about undergraduate level work in genetics? Again, just so I have an idea of, okay, terrific.
I have genes.
You have genes, yes.
They tell me.
Yeah. Yeah, this talk will be important for anybody who has genes or cares about somebody who does. All right, so that will certainly apply. Okay. Before we delve in, I'd like to mention to you something that I think this erudite group would be interested in. In a week from this Thursday, on September 20, I'll be hosting Sean Hopwood at Roanoke College, and you would be most welcome to come to his 7:30 lecture. Sean Hopwood has a very interesting background. I'll just mention to you briefly. He dropped out of college and didn't have any money, not much of anything to do, so he and a friend decided to rob banks. And so he did that quite successfully for a while till he was caught, landed in prison for 12 years. During those 12 years in prison, he wanted to try to study enough of the law to see if he could get out faster, and was unsuccessful, was not able to find anything in the law to help him. But he did find things that could help some of his fellow inmates. And in fact, he wrote 2 legal briefs before he went to college that made it all the way to the Supreme Court and won, which most attorneys never get to do. So after he got out of prison, he got his college degree, then a law degree from the University of Washington. He's now on the faculty of Georgetown University School of Law. And he'll be talking from an insider perspective, from somebody who's actually been in prison, but also is on the side of the law, about how we might improve and develop the way we handle incarceration. So I think it'll be a very interesting talk, and just wanted to alert you, this is a kind of group that I think would find it very interesting. Maybe some of you see him on 60 Minutes? They ran a profile about him, okay? So you have a chance to meet him in person. Okay. Science is very broad. There's so much we could talk about it. To make it a bit more manageable, I was going to go ahead and focus on the science of genetics with you. And maybe you've heard something like this. My genes made me do it. I could not stop it. I am not responsible. Okay? How about just for purposes of this group, we'll say that this will mean yes and this will mean no. How many, have you heard that, yes or no? Or yeah, I run into it often. Let's see. Here's a theological version. My genes made me do it, and since God gave me my genes, that must be what I should do. All right? So there they are. There are the culprits. You have about 3 billion base pairs in your genetic code. If you unraveled it from a cell and stretched it out, it would be about this long. Those 3 billion base pairs encode all of the information in your genes. I was working in a genetics lab, and somebody had posted this on the wall. It's a diagram of the Y chromosome. Of course, who has Y chromosomes? Okay, males do, right? And they had charted out for us the particular locations on the genes, where you can see at the top there, that's the gene for channel flipping. Down below that, refusal to ask for directions. Abhorrence of expressing affection over the phone. Lack of recall for dates. Fascination with the sports page. So it tells you quite a bit, according to this particular chart, what's in the Y chromosome. Should I show you the X chromosome? Would you be interested in that? Sure. Yeah? See the X? Okay. What they had posted for the X chromosome, we have drive for shoe acquisition. Upper right-hand corner, we have chocolate. Addiction to relationship movies. Upset if mate does not know why upset. Fascination with home decor, and then a real clash with the Y chromosome. You can see in the bottom right there, request and accept directions from anyone, regardless of their qualifications to answer. And so you can imagine how that interacts with the Y chromosome. Okay, of course this is silly, right? Genes are so influential and make such a difference, but can they account for this kind of behavior? Well, what do they account for? Take, for example, the human eye, incredibly complex. If I gave you a couple of $1 million and you could hire people for a lab, how many of you think you could actually probably design and make a human eye? I mean, is that... It's amazing when you think about the rods, the cones, the kinds of material, the refraction of the light, the ocular nerve that interprets the data. Incredibly complex. So could you make a human eye? I remember that probably everybody in this room, it looks like, has done it twice. So how did you do it? Your parents gave you something that were the full recipe and directions for making an eye, right? And that's coming through your genetic code. Your genetic code has all of the information for the chemical structure that's involved, for the way it's assembled, for the way the light is interpreted. I mean, it's amazing. Your genetic code has that level and detail of information. But it not only is there for our physical structure. Take this fellow. This cockroach, if you turn on the lights and he's on your kitchen floor, what will that cockroach do? Oh, it will flee the light. So how do cockroaches all know that they should flee the light? I mean, there aren't little cockroaches schools. They don't talk about this with each other. It's actually embedded in their genes. Genes can not only record structure, they can also record behaviors. So, for example, when we talk about instinct, about birds knowing to fly south at a certain time of year, and what direction south is, that behavioral information is in their genetic code. Okay? So what I want you to notice is that genes not only give structure, they also can give behaviors. And we've noticed this not only with animals, like a cockroach, but also with us, with people. And the evidence has been accumulating for decades at this point. We could already see back even in the 1990s that there were genes directly involved with seeking novelty. There are the people who go to a restaurant and always order the same thing. There are people who go to a restaurant and they want to see if there's something new on the menu. The people who want to see if there's something new on the menu, that's novelty seeking. It's novelty seeking is influenced by your environment, things that happen in your life, your choices. But we can also look at your genes and tell ahead of time that you are inclined to novelty seeking, even before we know anything about your environment, because genes influence your behavior. Genes can be associated with impulsive action. They can be associated with anxiety. We can show a picture like this to somebody, and by looking at their genes ahead of time, we can tell how strongly their amygdala will respond when that picture shows up on the screen. All right. Some people are wired to be more alerted by external stimuli than others. Everybody responds to their environment, but some people really are on a more sensitive trigger, and it's part of their behavioral genetics. And it's not only general behaviors, there are also conditions that are dramatically impact our lives. This is from an early study, for example, finding a link between a particular gene and familial schizophrenia. Now, I don't want to fall into genetic determinism. That's the old problem of reductionism, or what Donald Mackay called nothing buttery. You are nothing but your genes. That we don't want to do. And let me give you an example to think about this. Sometimes physicists talk about the theory of everything, that if they could just understand how particle physics work, they would understand the world and everything in it. But even if they could, along would come a chemist and say, that's great that you understand particle physics, but there's a level of complexity in chemistry which is just as real and which you haven't even addressed yet. So for example, in chemistry, we can see how different atoms work together to form a molecule we call glucose. And there's more to glucose than just protons, neutrons, electrons, and subparticles. There's a level of organization there that's of interest and importance. And along comes a biochemist and says, that's great that you know what glucose is, but if it's part of an ATP reaction that causes the release of energy and muscle contraction, that's part of reality too that you haven't even begun to talk about yet. So you've really got to have biochemistry. And then along comes a physiologist. Here's a picture of vocal cords. You can see there the collarbones. The physiologist says, well, it's not just particle physics and chemistry and biochemistry and an ATP reaction. It's causing a particular muscle to contract. And you don't really understand what's going on in this situation unless you realize the physiology. And then a neurologist says, well, it's not just random that the muscle is contracting. There's a level of complexity of a brain that is telling that particular muscle to contract in that particular way. And then a musician says, in fact, that person is singing beautiful music. And if you don't understand music, you haven't fully described the reality yet of what you're seeing. And then an economist says, well, but it's all about money. And actually, this person is being paid to sing. And so you have to realize the economy if you're going to understand what's happening. And then the sociologist says, well, but they could have sung for money somewhere else. They're singing in this particular place because they're part of a choir that has their friends in it. And that's the particular location. You've got to know the sociology if you're going to understand the situation. And then a theologian says, but do you notice they're singing the Messiah? And that they believe that they are worshiping God as they sing in this choir together. That if you don't understand the idea of God and of worship, you haven't fully understood the situation yet either. Okay, my point. Human beings are intricately complex, living at multiple interactive levels. Where we live, we're constantly expressing not only physics, but chemistry, biochemistry, sociology, physiology, neurology, economics, theology. Human beings are complex at many different levels. So whether the human soul, our will, emotions, our person, is a separate entity intimately linked to one's body, or an emergent phenomenon of one's body, both interpretations can affirm that there's a deep mutual connection and influence between soul and body. When the body is tired, the soul finds it hard to pray. It's all deeply interrelated. So reductionism is elegant but impoverished. It so focuses on one aspect of the subject or event that we're rendered blind to the rest of the connected reality. I'll give an example. Dean Hammer published this book a number of years ago, The God Gene, How Faith is Hardwired into Our Genes. It sold millions of copies, made a lot of money for him. It really should have had this title: A genetic sequence, VMAT, which may be associated with a tendency, less than 1%, toward an experience of perceiving self and non-self as one. But my guess is that wouldn't have sold as well as the God Gene. All right? He thought that he had probably found a particular genetic sequence related to behavior that had a very small tendency, less than 1% measurable, toward experiencing self and non-self as one, which is associated with some religious traditions. But even in that case, to call it the God gene, it's just much more complex than that. There's much more going on in human life than anything you could track back to just one gene in that regard. You see, genotype, your genes, are not even phenotype. Phenotype is the body you end up with. So, for example, if you have identical twins, they have the same genes, but they'll have different fingerprints. Okay? So fingerprints is part of your physical body that are not determined by your genes. Your genes might influence the kinds of whorls and such that you have, but the actual fingerprints you end up with are not determined just by your genes. So genotype has a tremendous influence on your physical body, but that by itself doesn't determine everything about your physical body. Okay? And phenotype, the body you end up with, is not all that there is to being human. Identical twins look a lot alike, but one might choose to be a carpenter and the other one a physician. One might become a Buddhist, the other one a Christian. Even people with identical genes are distinct and different people. Now, it's different for this fellow. This is a worker ant. This worker ant comes with a genetic code for certain behaviors, which it will do whether you put it on a tropical jungle or on an iceberg in the Arctic. It's got behaviors built in that it follows rotely. And so not only does it have 2 antennae genetically and 2 eyes genetically, it has certain behaviors that it's just born with and will do no matter what the circumstances are. Now, as you get to more complex life, see these Labrador Retriever puppies. They come with behavioral genetic instructions too, but they're at a level of complexity that they don't have to follow them rotely. Anybody ever raise a Labrador Retriever puppy? Okay, some of you have. What was it called? A couple of you nodded that you had one. Wendy, okay. Do you happen to remember what happened the first time Wendy was ever presented with a bowl of water or a lake or just a body of water? No. Don't remember? Okay. Well, I can guess, and as John is saying, most Labrador Retrievers, when they're presented with water, will start to play with it. They'll even jump in if it's large enough. It's a behavior that's built into their genes. They love and are fascinated by water. Anybody ever raise a dachshund? Okay. How did your dachshund react to a lake? Sunk like a rock. Okay, so good thing that you were there. Okay. Dachshunds do not have a behavioral tendency to want to jump into water or to be associated with water. Okay. These are behaviors that are built in. But you can train your Labrador to only go in the water when you blow a whistle, or to only go in when you give it a command. It has a level of complexity. It can make genuine choices in how it responds to its behavioral tendency to immerse itself in water. Okay, let's get to people. You go down to the refrigerator at night, and you open it, and what's inside is celery and Ben & Jerry's ice cream. Okay? Which probably looks most interesting? Okay, well, that's pretty predictable usually. You notice it's only the Ben & Jerry's in this picture that have combination locks on the lid. Okay? We tend to have, most human beings have a natural propensity to prefer the taste of fat. That's the juicy steak or the creamy premium ice cream. And there's actually a good adaptive genetic reason for that, and that's most human beings in history have lived where calories were short. And so if you've just got a few minutes at the kill before the lions arrive, go for the bone marrow, go for the juicy part of the meat, go for the fat-rich sources, because that's the quickest source of energy. And most human beings have a tendency to be attracted to, we think of it as that juicy steak or the rich ice cream. It's the taste of fat is very attractive to us. But we live in a time where calories are in abundance for most of us here. And so the best thing to do is not always to go for the most fat. We can consciously make a choice and say, okay, I know I have this genetic tendency to prefer the taste of fat, but I'm going to enjoy munching on this celery. We can make choices like that. We have a genuine genetic propensity to a particular behavior, but we can decide which behaviors we will encourage or resist, or how we'll express them, or what we will do with them. I'll give you another example. Almost all human beings, moms and dads, have a FOSB gene. A FOSB gene is a gene that gives you a biological reward. It feels good to feed your young. Now, the exact same behavioral gene is found in mice. And if you knock out the FOSB gene in a nurse mother, in a mother mouse, and you put it in a cage with its young, it will be more interested in foraging, looking for food, than it will be in holding still for its pups to nurse. And in fact, it will allow its pups to starve to death in the same cage. If it has the FOSB gene intact, it has a biological reward for the behavior of holding still and nursing, and it will prefer that and do that, and then the pups survive and pass on that genetic tendency. Okay? Now, that does not mean that if you have a human being that lacks the FOSB gene, that they'll starve their children. But there is a biological reward that encourages them to feed their children. So again, if the genetic behavior is not present, you can still choose to do it. At a human being level, we have the ability, the complexity, that we can shape, we can resist, we can encourage, we can work with the genetic tendencies that we have. So our genes do influence our mental life, but they do not determine all of our bodies, let alone all of our behavior. We need to encourage, resist, or channel our genetic drives and tendencies as is appropriate. Our genes usually encourage a course that has worked. That's no small benefit. But they do not definitively tell us what we should pursue. That the level of what should we do has to be higher than what do we have a biological tendency to do. And as human beings, we can make genuine choices. Now, evolutionary psychology hopes that how we develop certain traits gives moral weight to pursue them. You've probably heard of people like E.O. Wilson arguing this in Consilience, James Q. Wilson, The Moral Sense. But essential to the theory of evolution is that structures developed for one use can be turned to another. And we could come back to that if that's helpful. I don't think we have time to talk about that in detail. But the theory of evolution is that structures that develop because they help you survive can be turned to other uses. And we have many examples of that all through evolutionary and genetic history. I'll give you some more examples. The clearest genetic marker we have for criminal violence it's very simple and easy to measure. The clearest genetic marker we have for criminal violence is a Y chromosome. Okay? Are there people who commit criminal violence who don't have a Y? Yes. But the dramatic, universal, global experience is that most criminal violence is perpetrated by people with a Y chromosome. Okay? So there's a strong genetic marker. Does that mean that if you have a Y, you have to be criminally violent? No. You have a level of complexity and choice. You can decide what to do with that built-in behavioral genetic tendency. Another example would be that there are many people who suffer from alcoholism that we don't currently see any genetic link. But there are people who have a particular gene which dramatically increases the chance that they will indeed have to deal with alcoholism. Now, if they have that gene that gives them a propensity to alcoholism, we don't say, go therefore and be a good alcoholic. We say, this is going to be tougher for you. This is a tendency which is running in your family, and it's going to make it harder for you to resist alcoholism, but you can, and we'll work with you to do that. Simply having a genetic drive does not establish if it should be carried out, nor if it should be, how or when. Some genetic tendencies should be encouraged, some should be resisted, some are fitting in one case and not another, some are simply idiosyncratic. They're just part of your unique and special, welcome, diverse personality. So you might think of it this way. Your genes give you the lay of the land. And you notice in the background, I've been using what looks something like a topographic map. Okay? Your genes kind of give you the topography of your life. They give you a surface on which you are working. But you are still deciding which way you're facing and where you're going and how fast you're going. You're influenced by your genes, but in most cases you are not determined by them. Now, some genetic influences can be deeply influential and are much harder to work around. Some are lighter and easier, but it is a topography. You can make choices as to what you do with it. Or think of it like this sailboat. The direction and strength of the current and the wind is the environment. The shape of the hull of your ship and the condition of the sails are your genetic heritage. How you set the sails and how you turn the rudder is a matter of your will and choice. And it's the interaction that very much becomes who you are. Now, we probably all know examples of people that have incredibly good sails and the wind's at their back and they're just sailing in circles. And we've probably also been inspired by people that have terrible holes in the sails, the hull is leaky, the wind's against them, and it's amazing what they accomplish. We're a combination of these things. There's no one part of it that is utterly determinative. So you might say this: our genes destine us to be free. Our genes destine us to have some genuine choice in what we do with our genes. We all have genetic drives and tendencies that we should follow and others that we should not. So we have to discern which is which. Focus on the good, enable the good, become a person who naturally and freely chooses the good. Romans 12:2, do not just reflect this world or your genes. Rather, be transformed by the renewal of your mind so that you will live God's good, pleasing, and complete will for you. It's not automatic that you live well. It's a matter of choice, and I would argue turning to God and God's grace to ask for help, and then work out your salvation with fear and trembling, for God is at work within you. That we can ask God's gracious forgiveness and also strength and guidance and help as individuals, as community, to learn and to grow and to do the best we can with what we have. Positive change for ourselves and others will often be incremental, requiring encouragement, and will often take time, requiring resolute compassion and patience. When you are shaping your life and who you're going to be, it doesn't always come quickly or easily. It's more a marathon than a sprint, more learning an instrument than a single song. Don't expect living the Christian life to be easier than learning Spanish. The things that really count in life, you have to pursue over time and to consciously develop. It's not just a one-time choice, it's a continual series of choices to embed and develop new patterns. And what we're looking for is more harmony than unison. It's amazing the wonderful variety that God has created among His people, that He talks about the body of Christ, our church, as being a place where you have very different members of the body, but that learn to work together in Christ to achieve so much that anyone could alone. So people come in all shapes and sizes. Think of Gregory of Nazianzen, who writes of James and John, the sons of thunder, thundering the Spirit. Or Saul, aggressively persuading, pursuing, cajoling to stamp out the early followers of the way of Jesus. And then he becomes Paul, spreading the way with the same temperament. But now he's turned that temperament to service of the good news rather than to resist it. So the idea is not that we all become the same. There are some things that the Christian tradition reveals God intends for everyone, that everyone by God's grace should learn to have love, joy, peace, patience, goodness, meekness, temperance, self-control. But there's also tremendous variety in how that's worked out, and it's the richness and variety that can make such a difference. So there we are, all shapes and sizes. I think what God holds us responsible for is what we do with what we have. And our genetic structure and our genetic behavior is a major part of what we start with. by God's grace, it can be transformed, guided, used for a healthy and good life as individuals and with one another. I'd argue that God sees the heart. And that's what we're responsible for. It's what we do with what we have. The ultimate inheritance. Martin Luther commented on 1 Peter 1:4, "Our inheritance is imperishable, undefiled, and unfading. It is only for a little while concealed from us until we close our eyes and are buried, when if we believe, we shall surely find and behold it." All of our inheritance, not just genes, but all that's been planned for us. If you'd like to think more about kind of this ethical and theological aspect of some of what we just talked about in regard to genes, Genetic Turning Points, The Ethics of Human Genetic Intervention is one of my books on this you could take a look at. Or Changing Human Nature, Ecology, Ethics, Genes, and God. So these would be some resources. And that's a quick overview of this idea of my genes made me do it. So what would you like to come back to and comment on, ask about, challenge? What would be most useful to you?
How do you find out what you have in order to make a decision about what you do with it?
How do you find out what you have?
Yeah, what do you...
You can certainly have yourself described genetically. As of 2003, there was just one complete set of the human genome that had been spelled out, and it actually came from multiple different people. And that particular effort cost billions of dollars. We called it the Human Genome Project, right?
Not covered by Blue Cross.
Not covered by Blue Cross or Blue Shield. It's amazing. I was just talking with Francis Collins about this a couple of months ago. He's the director of the National Institutes of Health and is in a very good position to know. And he was saying that he thinks that having your entire genome read should be down to about $500 within the next year or so. I think it'll get down to a price level where it'll become kind of part of a routine physical. Everybody will have a readout of their genome. Now, it's a whole other step to understand the code. But being able to read it, we're actually technically getting pretty adept at it. It's amazing how it's developed. But do you remember how many base pairs in your genetic code? 3 billion, okay? We're talking about huge numbers to read and to go through. So you have to use automated methods to find the things you're looking for, okay? So will we be able to read our genes? Yes, we're getting better and better at that. The whole field of epigenetics is where you then try to understand not only what genes you have, but which ones get turned on, get turned off, how they interact with other genes, how they interact with the environment. That's immensely more complex, and that's unfolding, but is going to take time. The most powerful tool we have to do that is called CRISPR-Cas9. And our plan as a Sunday school is next week to talk about CRISPR-Cas9, what that is, how it works, what it can tell us, what we can do with it. So that's some of the technical in response, a very appropriate question. As far as the quickest way to understand where our genetic tendencies are is we can see the tendencies in our life. Some of them are built into our physical heritage. Some of them tend to come more from environment. But what we're responsible for is what we do with our tendencies. And so if you've got a tendency that you can see a positive way to channel and use it, do so. If you've got a tendency that you think, boy, I'm not sure where this comes from, or maybe I have some idea, but I don't really want to do this, or it's appropriate to do here, but not there. So I think there's a dialogue that needs to happen, being shaped by Christian community, by Scripture, by God's revelation and work in our lives, to take our tendencies and to not just willy-nilly follow anything we feel like, but to consciously make choices about who we want to be and who we want to become. So those would be some reflections on that, if that's helpful at all. Okay.
So the reason I have this mic isn't to interrupt you, although I'm doing that. I have the correct mic now, and we do have time for more questions, if that's fine. I do want us to use the mic, though, so that because we're recording it, people that are going to listen in throughout the week, they can hear your question. So, okay, hold up.
Okay.
Just let's go. Richard on the way back to James.
All right. A lot of this is beyond me, really. So this is on point, but maybe not exactly. But things like Ancestry.com seem to me to be related to what you're talking about, and how two children in the same family can have different genetics or ancestors or whatever that is. That escapes how that works. Is that related to what you're talking about? Could you speak about that?
Sure. A service like Ancestry.com, depending on how much money you spend and how you interact with the site, can do an analysis of the genes you've inherited, and they generally kind of give you rough ethnic groups. How many of you have actually done Ancestry.com? Okay. And then there's 23andMe as another example. These services are usually pretty accurate, although they don't go very far in interpreting the data. So if you do 23andMe, it might tell you you have certain tendencies, but it only goes as far as the genes do, and that fairly generally. Ancestry also looks at what you can say about who you've been related to in the past, and they compare that with other people's family charts, and so they can give you potentially more detail about particular people and places and times. So there are services out there that can help you learn more about your ethnic heritage. There's no current service that gives you detailed knowledge of particular behavioral tendencies that you've inherited. That's just a bit more complex than anybody's offering commercially. But there are many studies are going on, and a great deal of research is going on, so that we're getting better and better at fine-tuning that. So I gave the example of alcoholism. Many people suffer from alcoholism that we have not found a genetic trait for it. But there are families where we found a particular gene, and we can tell that a child that's raised, say, by adoption in an entirely different family has a greater chance of alcoholism than their siblings raised in the same family, and we can see that genetically. So some things have a strong genetic component, some things we haven't actually seen yet how much of it can be or if it's always genetic. So it gets complex quite quickly, or quite appropriate for you to be aware of that. Yeah. I think there was a microphone.
Yeah, I just want to get your thoughts on artificial intelligence, AI, and how we're going to handle it and where you think it's going to be in a year, 5 years, 10 years from now. I mean,
Well, artificial intelligence is very good at analyzing mass amounts of data. Learning from that data is much more complex and is the growing edge. And whether it'll ever get as good as human beings is a very fair question. Human beings not only have trillions of neurons, but each neuron has hundreds of different ways of firing. And when you start measuring hundreds times trillions and then put it in a network, the human brain is incredibly complex. And whether we'll ever be able to do that with hardware, with a silicon-based computer, probably not. Will there be a new technology that will develop that can get closer to paralleling? Possibly. But that's probably a whole nother Sunday school series, isn't it? Yeah, okay.
All right. I see a question right here.
Is there any evidence that humans possess a kind of metagene that seems to influence the probability that they will exercise their free will when other genes come into play?
Let's see, a metagene that encourages free exercise of will?
Or limits that affects the probability that the human will indeed exercise.
By metagene, do you mean an individual gene that has a broad-based effect? Okay. I think there's a tremendous adaptive advantage to being adaptable, to being willing to see things in a new way, to be willing to act in a new way. And that's also why social evolution happens much more quickly than physical evolution. So if you wanted a good adaptive strategy to build into your basic structure the ability to change your clothing, to change your location, to find food in a different way, adaptation is extremely helpful to survival. I'll give you a real concrete example. We can look at the dominant human species in Europe, the Neanderthals, that had the same system, we can tell archaeologically, they had the same system of using short, sharp objects to run up to large animals like mastodons and stab them to death, which was a great source of protein, but also when you look at Neanderthal skeletons, they have all kinds of broken arms, broken legs. I mean, this was a really risky way to make a living. And they did that for 100,000 years. Think how much our relatives, Homo sapiens, have changed our behaviors in the last 100 years. So I think the genetic propensity to be willing to change and adapt is a crucially important part of how we came to be and of our success. So that would imply that there's some combination of the genes that we have that encourages those adaptive behaviors that are extremely important to survival and to a kind of free will.
Yeah. You mentioned that you're not a strong proponent of genetic determinism. Is that right?
Well, I'm arguing against determinism, yes.
Okay. And I was just curious, is that widespread? Would that be widespread among agnostic geneticists?
I do think that philosophically and theologically, that through human history there have been lots of people who've thrown out the idea that everything's determined and decided either by God's decision before it even begins, it's all been decided, or that human beings at the most basic level are at that particle physics level where things happen just structurally and by rote, there's no decision involved. I think it's turning out that the world is much more complex and interesting than that. So if you've read it all, for example, about quarks and about indeterminacy, how probability works, I think you can make a strong scientific argument that things are not determined and that the way the world goes, if you went back and you started running it again, it wouldn't come out exactly the way it has so far. That there's real change and choice that's taking place. And then I think just personally, I sure feel like I make choices. So my own phenomenological personal experience is that I make choices. And I would expect probably that you feel like you do too. And I think that's actually rooted in something that's really happening. So a great classic perennial question. Those would be some quick observations that I would make.
We probably have at best, which we don't have a huge amount of time, but one last brief question. Does somebody have something that you... Really? Okay. Well, thank you so very much.
We've got 2 more sections and lots more things to talk about. We'll talk about CRISPR next time, which is a new development in genetics that is transformative. It's like the invention of the printing press or of the computer. It's so formative for everything that's alive. Wow. And then on our 3rd time, we'll talk specifically about a theological perspective on changing human nature. So that's what we're planning the next 2 Sundays.
Well, this is fantastic. Thank you so much, Dr. Peterson, for being here. We really appreciate it. All right, if you've been to church, have a great week. If you haven't been, we'll see you there in just a few minutes. God bless.